All right, so Banu is from the Faculty of Science and Engineering, and he's going to talk about machine learning for advances in flood prevention.
Okay.
Oh, wait, that's prediction, presumably with the plan to prevent them.
Thank you. All right, and so it's kind of a afternoon. So very good afternoon, everyone. So actually, it's my first presentation in Australia. So honestly, I have no idea of this one. So since everybody was saying like, so we have to acknowledge the country. So I'm sorry if I pronunciate something wrong on this context, like for this Ugamba people and all, right? So I would acknowledge, but maybe in the future presentations, I will like make sure I'm pronouncing everything properly. All right. And in addition to that, acknowledge the country, I would like to acknowledge a few more people like the SEP, especially for the praxis, for having this, and my supervisors, and my parents, of course, and the audience for listening to me. All right. All right. So this is Barbara Ward. So let's see what she has told. So we have forgotten how to be good guest, how to walk lightly on the earth as the other creatures do. So just remember this statement. So I'll come back to this a bit later, right? And in addition to that one, maybe you can have a small clip. All right, so I hope you all have have an idea about what I'm going to talk about today a bit. So floods is a kind of a huge impact. So as my PhD student, so I was planning to kind of implement a system. So for predicting the flood ahead, like with a long lead time, so that we can think of reducing some kind of impacts which we can cause, like mostly in the form of cost, right? Money, right? So as you everybody know, like at the start journey of the PhD starting journey, so we have to go for a literature review. So I have done it in the systematic way, so that I can have a systematic mapping study to find all the flood prediction related studies, so that what are the things are there, what is lacking, what's the problem with the current studies and all. So it's me, Banujan. So I'm and with the supervisors, Golam Sovar and Ali and Dr. Fefi, right? So I haven't done the COC yet, so it's my pre-major study, so I have not much results for that one. So to make you aware of these flood-related matters, so this is actually 2023 mortality rate. So the top 10 countries, like the top 10 disasters. So you can clearly see like the flood has like out of 10, so 4 has, it is based only in the mortality. So 4 big events out of 10 is from the floods. And this one, so you can see the results of the CRED, so which is like the occurrences of the flood. So it is 164, right? So for when it comes to all the natural disasters, so it is 164 in 2023. So 2003 to 2023 as the annual average, it is 170, which is 6 less than the annual average of last 20 years. But still 164 is like a high number. So when you compare to the other disasters, so earthquake is 32. So the frequency of the flood is so high. So this is the global statistics, right? And you can see the Lismore flood, so how it affected in the last year, like couple of years back in the February. So these images are retrieved from the different sources, so you can have an access of those things. And this one, so I visited the Lismore last year in December to have a site visit. So this is the a brown screen pump station. So see my height, and this is the levee height. So usually in the Australian context, from the sea level, it is like approximately 10.5 or something is the levee height. So that is the kind of a temporary protection. So for the floods. And the last year in a couple of years back, 2022 February, it's 14.4 meters. So which is like 3.5 meters, like approximately 3 meters high than the levee. So that is normal person high is like a 1.8 meter. So it's how much deadliest it is, right? And so by considering this, my objective is for the today's presentation is based on to find or summarizing the advances in the flood prediction based mostly on the machine learning and deep learning techniques, right? So to achieve that, so I have planned some few research questions. So which is basically how the temporal publication trends are there. So how the publication has evolved and which countries these studies are based on, because I want to know how many studies are there in the Australian context, right? And what types of different floods are there and what are the factors and what characteristics are for the flood prediction system and what are the algorithms used. So which will be like my major part. So where I have to improve in my study. And what are the major limitations and challenges are there, which I should address in my study. So to begin with, so I started a systematic paper search, so which I have three major keywords in three major areas on my study. One is the flood related one, and the technology related one, and the prediction related. So keywords. So these are the keywords I used to extract the papers from the databases. So I found all the relevant keywords on these three contexts, and I combined the Boolean method to find the studies from the databases. And once the studies are filtered, so I used these inclusion and exclusion criteria to find the relevant papers. So as you know, like when we go for a basic keyword-based search, so it always gives us lots of papers. Most of them is not relevant for us. So we had to do some kind of a scope so that it affects only for our papers. So I have made the inclusion criteria is like it should be based on flood prediction, because in the context of flood, there are lots of different studies. For example, it can be risk analysis, post flood related matters. So I should focus only in the flood prediction, and flood prediction can be achieved in different ways, like physical models and some other things. So I am focusing only in the data mining aspects. And there are some few exclusion criteria which is common for most of the literature reviews. So which is like it does not have the abstract, and it is just published as the abstract and the English, and there are some older versions of the previous studies, and it is not a primary study. So those kind of exclusion criteria I have used. So this is the overall map of my selection process. So I used IEEE and Web of Science and Scopus as the major databases. So from my previous slide, you might have seen the keywords, list of keywords I have used. And those keywords were applied in here. And you can see I was able to get like 5,478, which is quite a number of high papers, right? So from that, so since Web of Science and Scopus, will retrieve a lot of duplicate, like same papers are there. So after removing the duplicates, so you can able to see like around 3,663 papers were remained, and 1,815 papers were the duplicates. And then we applied our inclusion and exclusion criteria for the title abstract. So I was able to get around 468 papers. So then after I did snowballing and the research group. So I hope you are aware of the snowballing in the sense while reading those studies references, so we can find more papers which are not included in our search. So that is called as snowballing. So by using the snowballing and by using the research group, like some extra searches in the research gates and Stack Overflow and some kind of research groups, so I was able to find 5. So totally at the end, I got 504 papers, which is related to my study. I have gone through all of them. It is way high, I know. I spent more than 4 months. So from that key finding, the first one, the temporal, you can see. Oh, sorry, I missed something. So it is like 20-year study. It started 2004. I filtered the data from 2004 to 2023, right? So out of approximately like 19, 20 years of study. So, and you can see how the research has been bloomed. So it is started very in the early period, like only 5, 6, like maximum 36 until 2019. So from the 2020, 21, 22, 23, the bloom is there for the research on the flood prediction. The reasons I realized is, one is the advancements in the deep learning technologies. So the technologies have improved. So that's one major reason. Second one is, so in the context of data mining, so we need to have a historical data, a kind of a past data, I mean, in the flood context, the rainfall data, the flood data and all. So then the machine learning can learn the pattern. So if we feed more amount of like a past historical data, so it will learn the pattern and it will help us to predict the future. So in the early period, the people were not aware and we didn't have a proper digital system to save the records, the rainfall records, temperature records, and the flood related records. So therefore, like most of them are manual and they were like, the manual records were like removed and all because of, you know, the papers, they deteriorate over time. So therefore, the awareness was created in the 2000s and people started to save the data. So these are now in the digital form. So that data is now being harvested. So we need a historical data, then only the performance will be good. So that's the second reason. And the third reason is like increasing the frequency of the flood. From a previous slide you might have seen, so it's 164, the occurrences of the flood, right? And if you see the country, so I'm sorry for the small fonts of the numbers because it's generated from my programming, so I couldn't enhance the font, but I just go through. So USA have 30 studies. The top one is China having more studies done, 76 studies done, and India has 61 studies done, and USA 30, Malaysia 29 studies done out of my paper selected, 504 something. And in Australia, it's only 6 studies. And those studies are like 2019 only one study, which is based on very basic machine learning algorithms. And the previous studies are 2015, 2012, and 2011, if I'm not wrong, and like very long period back. So, and in addition, like so I try to understand what are the different types of floods are there. And in the context of Australia, so we have the rainfall-driven floods as the most affecting. So we don't have much of these snow melting floods or like ice jam floods and infrastructure dam breaking or levee breaking floods. So most of our cases are like falls on the rainfall-driven because so we have the different like variation of the climate patterns in here. So especially the flash floods, riverine floods are the most important in the context of Australia, and most of the studies have focused only on these ones. And so for most of you with the general idea, I guess, so we might feel the rainfall will be the prominent factor to force the floods, but it is not the truth. So it is one of the factors. Right? It is one of the factors. But in addition to that one, so we had the temperature, humidity, and the wind speed, and these like the slope, how the buildings are, the land use, land cover. So, and similarly, there are lots of other factors which are like kind of not even in the high level, but with the minor level, they are affecting. So if we can analyze all these different types of factors, like in our context, so it might give more value, more valued prediction. And so in my case, I will be focusing mostly on the meteorological factors, hydrological, and the flood-related factors. And when you see the characteristics of the flood prediction system, so it will be like on the like the real time, so where we can like predict or do the analysis in the real time, and near real time means so we get the data and study for a period of time, and then we release like it depends on like few hours or something. And regular intervals, like in like every every day morning 6 o'clock, so we can predict. So it's too technical. I'm so sorry about that one. And these are also kind of technical, like, so we can have different prediction types of system, which is short lead time in which can predict like 2 hours or 3 hours before. So my aim in my research is having a kind of a medium and long-term prediction. So where people can like think of like getting some proactive actions for them. And in addition, there are some multi-step. So it's like we can predict only for the third day, or we can predict like first day, second day, 3-day, like regular interval prediction, so that people can realize, okay, so now I have after 6 hours, this much of level will be there. After 12 hours, this much of flood might be there. So like that, they can have some understanding. And the uncertainty, so it is a bit complicated, more related to the statistical part. So natural events, it's so hard to like predict because its uncertainty is always there. So in my research, I am thinking of incorporating how I can solve that issue, because we can't have a 100% prediction system, so all you know, at maximum performance level, right? And sorry for this one. So this will be too much technical. So I just wanted to emphasize in here is like, so there are these algorithms have been, these different types of algorithm has been used. So these are not algorithms, these are categories. So there are a lot of names of algorithms are there. So my focus will be on the machine learning, especially in the deep learning or hybrid algorithms where we can combine. They are more sophisticated, more advanced algorithms. So I want to like think of how I can enhance in my study. And the basic limitations are like data related one and the modeling related one. So complexity and how long data. So as long data we have, the prediction will be more success. So in the Australian context, so my target will be on the tweet catchment first, and then to the Richmond catchment where the least more area is. So on that basis, so I have to like, I'm searching, I have received few databases, but I have to check. But another problem is, even though we have the data, there will be some missing values, there will be some kind of outliers. So I have to find a way to fix them too. So maybe I will get like more success on that one. Okay, so as a conclusion, so these recent advances have paved a long way, like in the deep learning, and the data has paved the way for the more accurate flood prediction. And thank you, and open for discussion.
Thank you, that was awesome. Okay, so we've basically got time just for one quick question.
Yeah.
In
your data analysis,
Yep.
Is it frequent or cyclic? From 10 years or 15 years of data you consider?
Yeah, 20 actually.
20 years?
Yeah.
Is it cyclic?
Huh?
Cyclic.
Cycling in the sense?
The phenomena of inundation, atmospheric rivers.
No, because it's so simple, straightforward. Mm-hmm. So in our case, I have my keyword search first, mm-hmm. and then I have my inclusion and exclusion criteria.
But keywords also, you have so many research questions.
Research questions? Okay.
So many research questions you have, 7 research questions.
Yeah.
And it is a bit confusing that you choose so many keywords from each and every research question.
No. The research questions are for the analyzing of those studies. Mm-hmm. The keywords are to find the studies. Okay. So I first get the keywords and find the studies. From those studies, I extracted those research questions. So answer for the research questions are there. So it is not, I don't know like that I am explaining correctly, but like, so the keywords are only for finding the studies, because I don't know which studies actually exist. It's not just a Google Scholar search.
Because I'm doing similar analysis. Mm-hmm. And another thing, the prediction must be accurate if you consider satellite imageries of different spatial and temporal dimensions. Mm-hmm. That will be useful for predicting the atmospheric rivers.
Yeah, that's a good suggestion. I appreciate it. But the problem is like when you go for the image processing, so it takes more computation. So it will take more time. So the prediction will be delayed. So at the time when I'm predicting, it might be already flooded. So when it comes to image processing, so we have the forecasted value of the rainfall. So we can use that for the prediction. So it's based on the numerical data. So easy for that one.
So these are questions are not for your PhD.
Oh no, it's just for my mapping study. Yeah.
I thought that was fascinating. I didn't understand all the words around that engineering part and all this fantastic, but living in a flood area up in far north Queensland, I completely appreciate the work and potential of what this can do. You said you'd focus on the Tweed area and then another area.
Richmond catchment.
Could you see that what you gain from this could be transferred across Australia to other, and that you'd be able to apply your work to other places, other flood areas, so that there can be more of a lead in to being able to respond appropriately, so people don't lose their lose their lives and lose their houses, I guess.
Yeah, of course. So that's a great question, actually, and that's a great suggestion. Actually, my study is for generalizing. So I'm going to implement it there for the testing purpose. So since in my case, I'm using the data mining, I don't need to be like a specific bathymetric details or something I don't need. I just need the historical data. So wherever we have the historical data, so I can implement it. So as the pilot study, first I'm going to do it with the Tweed and then to the Richmond and then for the whole Australia.
And then someone else who wants to do their PhD and take that on and try it in other areas.
Yeah, thank you so much. Yeah.
All right, we just got time for one more question.
You said at one point for us to remind you about that quote you gave us from Barbara Ward. You said for us to remind you about that.
Oh yeah.
Yeah.
Oh yeah. Thank you. Because of the time limit, and I just stopped. All right. So the reason I put that slide is so we have changed the landscape. So the major reason for the flooding is, so we changed the landscape. So we started building the buildings, urbanization, and you block the land. So where the water will go, it will come to your area. So you forgot how to walk with the nature. You change the nature. So then it will come. So thank you so much for reminding.
Thank you,
Much
Banu.
appreciated.
Thank you.
Thank you.